question number 6. And also question number 7, because they're quite similar. So I like to put them together. Yeah. And actually, this is a continuation from the previous example. Yeah. Because the knowledge we use closely related. The knowledge we use, that is here we use the concept we used here, the order of growth. We compare the order of growth for certain functions. Yeah. Here, for one is because we need to look at the log function, and another power function, and a third exponential function. Yeah. Here you can see all the expressions related to these 3 types of functions. Yeah. All right. And the reference still the same as the previous one. So that is, so for the reference, still that module 3C, and that's basically module 2 E.3. Okay, yeah. And here I like to point out the fact 1. Okay, yeah. So that is the order of growth of the exponential function a to the n is higher than any than that of any power function. Yeah, so we know just D positive. So that's fact number 1. So when you compare fact number 2, okay, the order of growth of the log function is lower than that of any power function D positive. Second fact. Okay, all right. With these 2 facts, so then you can do comparisons. Yeah, but here you also, because some students feel this part pretty tricky, log function is at a denominator, right? Yeah, so that's a little special. Yeah, all right. And so here, one way to consider. So one way to see the order of growth better is, yeah, can you imagine that the log function is approximately n to the epsilon power. Yeah, I hope. So here we borrow that epsilon from calculus. Calculus, you know that, epsilon delta language, right? Epsilon delta language. Yeah. Although you may, I mean, I do not ask you to be familiar with epsilon delta language. Here, this special epsilon we mean epsilon is greater than 0 and less than d, d, for any positive d. Yeah, so that epsilon, just a special symbol, it has this special property. First, it must be positive. It cannot be 0. It must be positive. Second, it is smaller than any positive number, any fixed positive number. Yeah. So you use this property, special property, for that epsilon. Then when you compare with this one, because this is d, right? This d equals this very small number. It's a fixed positive number, right? Yeah. Then you can say that epsilon, because here logarithm approximately equal to n to the epsilon, but you can comfortably say that epsilon less than that d. When you do comparison, you compare epsilon and d. Which one is smaller? Which one is larger? That will be easier, a little easier, right? Yeah, so that's some special way to deal with functions involving log function. Also here, if you use this special method, now look at this. N over log of m, that special form, can you replace the log by n to the epsilon? Right? Yeah, so this time n to the epsilon, and you do simplification, n to the 1 minus epsilon, right? So the exponent number is 1 minus epsilon. Okay? And because epsilon is positive, right? So 1 minus epsilon should be less than 1, right? So think about that. Yeah. Very close to 1, but strictly less than 1. When you do comparison, you can use this inequality. Okay? Yeah. Then, but you also, when you do simplification, because you need to do simplification for some of the formula. When you do simplification, so drop the minor terms. Only keep the major dominant term, okay? Major dominant term. I hope you know the meaning of the minor terms, major dominant terms, right? Yeah. For example, for this one, you can drop the minor terms, right? This one, you can drop the minor terms, right? This one, you can drop the minor terms to do simplification. All right? Yeah. Here, this one, yeah. So if you use the epsilon way, approximately m to the 1/2, right? Times n to the epsilon. After simplification, n to the 1/2 plus epsilon. The exponent number is 1/2 plus epsilon. When you compare some order of growth. Yeah. So you have the explicit expression for the order of growth of this function. 1/2 plus epsilon. That's the order of growth number you can use in your comparison. Okay? Yeah. All right. So here I just give you one suggestion. Okay? Yeah. Although it is a little abstract, yeah, but yeah, sometimes we need to use some abstract thinking. Yeah. Yeah. Like this. Yeah. All right. So that's